Hi everyone. So this is an optimization of lead code 486. In here we have time and space complexity. If we go of n square and we want to reduce the space complexity. To reduce the space complexity, we can do one thing. Instead of this, let's create a single dimensional DP which will hold the values. And we are going to use bottom up approach. So new int of size n. So what we are going to do, we are first calculating the base case, which is for length 1. So for int I equal to 0, I is less than n, I plus plus. What are we going to do? In our DP of I, we are going to store nums of I. Since that is the base case, we have to pick up that exact number. Now then what we do, for every length, we are going to then calculate the, uh, you know, gain. So starting length 2. Since for length 1, we've already done that here, and for length is less than n. I will check this later, length plus plus. So what we are doing is essentially our start index would be int I is equal to, let's say I start from 0 and I run until my I has, so my j would be, let's do I plus plus. I'll just write the condition here. So now my end index would be j and it would be I plus length. Let's say my I is 0 and my length is 2. So I plus length minus 1 would be my j, correct? So this is my left and right. Now I plus length minus 1 has to be less than or equal to n. So if I say that this has to be less than equal to less than n, it means that I has to be less than n minus length plus 1, correct? This is my equation. And if I just remove plus 1 from here and have an equal to sign here, it balances out. So my condition becomes I is less than equal to n minus length. So this is my code here. Now what we do, we calculate, essentially we calculate the, now since we are building for every length from smaller length to larger length, we had two scores here, right? So we needed to pick the max of it. So let's do that here again. So now what happens? My DP of I would be mat.max of this nums of I minus score of this. Now we got this value from recursion. In here, this value like I plus 1 to j, and this is of k length, right? And j is here. So this will be stored in dp of I. So we can write dp of I here. So this gives me first value. What is the second value? The second value is nums of j, this. So here what we do is we have nums of j and score of from I till j minus 1. Where will we get it? So from I to j minus 1, we'll get it in I dp of from I up until j minus 1. So that will be given as I minus 1. So this is the formula. In the end, we are going to see score of 0 to n minus 1 memo. This will be dp of 0. If this is greater than equal to 0, we return true. Now, if I just remove this and run my code, so this is dp of I minus 1, this is dp of I, I'll say. See, because in here, this was score of I plus 1 comma j. And I plus 1, dp of I plus 1 will, for that particular length, this will exactly store my value. So that is the reason why we did this. So now let's run the code. Length 3. Okay, I think I need to do a check here, which says length has to be less than equal to So for every length, we have to calculate. Nums of j minus. Okay, I calculated nums of j here, but it should have been nums of this. J is not a variable here. There was a typo here. Here we had score of I plus 1, so that's why we had to do I plus 1. Because when I is 0, I minus 1 would have been minus 1, so index out of bounds occurred. So when I submit the code, our time is big O of n square, but now our space reduces to big O of n. So yeah, that was it. Why space reduces to big O of n? Because we have a single dimensional array of size n. So that is the reason why. So yeah, thanks for watching. That was it from my end. Bye.